Let's talk about designing flat-back power supplies with multiple outputs. Let's have a look at the existing solutions for multi-output flat-back. Over here, I've got a circuit diagram built on InnoSwitch, which is another power integrations product for flat-back. So this is the primary side of the circuit. This is the secondary side of the circuit. On the primary side, we've got this primary side of the transformer, the switch of the primary side. The switch is being integrated in the switcher. It can be a power GaN switch or a MOSFET. So on the secondary side over here, I've got synchronous rectifier for better efficiency. And feedback is being sensed over here, sent to the switcher to regulate the output over there. The output, let's say, is 12 volt. I've also got this really interesting technology here called FluxLink. It's an isolation barrier crossing technology, unique PI technology that allows you to not having to use any optocouplers anymore. So that's the circuit diagram for single output flatback. Traditionally, when we talk about multi-output flatback, we're normally referring to one of the two solutions. So the first one is multi-winding flatback. I've got 12 volt here already. What if I need another 5 volt? I simply just need to add another winding on the secondary side of the transformer. Really easy. Don't forget about your switch here, very important. You can use a diode. I'm using SR because it's better for efficiency. Your dot, 5 volt. That's it. As simple as that. If you want more outputs, you just add more windings. This solution is really, really easy to implement. However, there's a really big limitation here. So normally with this arrangement, feedback is only being sensed primarily from one of the output. And over here is my 12 volt. That's my main output. That output can be very well regulated. However, the regulation on the rest of the circuit, not so much, not very good. And you don't want that. Say for this 5 volt, the regulation can be as bad or even worse than 10%. So what if you do want accurate regulation on multiple outputs? So if you do want accurate regulation on multiple outputs, you want to go for flatback plus DC-DC. So I've got 12 volt here. If I want my 5 volt to be accurately regulated, I just add a DC-DC, say a buck circuit over here. That's my 5 volt. So by doing so, the regulation on both outputs is going to be very good. However, the introduction of this DC-DC circuit will compromise your efficiency in the system because you no longer just have a single stage of power conversion. Now you've got two. Say the flatback efficiency is, for example, 90%. And then my DC-DC buck converter efficiency is, say, 92%. So if I'm looking at a design where I need, for example, 5 volt, 2.5 amps, 12 volt, a 0.5 amps. If I want that, then my system efficiency becomes 85% immediately. And you see that's a 5% difference because of using the DC-DC converter over here. And also adding the DC-DC converter here means that you might have to enlarge your PCB size, add the cost, add more component count in the system, and you don't want any of that. So is that it? The answer is absolutely no, because now we've got InnoMux-2. So InnoMux-2 is a single stage power conversion. You don't need DC-DC anymore. That means I'm taking that out, no longer need that. Of course, that 85% gone as well. All I have is just a single stage flatback, 90% efficiency. Here I have the InnoSwitch-based single output flatback circuit. So how do I turn it into InnoMux-2? Here's what I need to do. I've already got a 12 volt. If I need a 5 volt, I just need to add a switch here. That's my 5 volt output. Some output capacitors here. This switch is what we call a steering FET or selection FET that's used to steer power only to the output that's requesting it. The control is integrated in the IC. Only adding the selection FET is not enough. I need to add another blocking diode on the 12 volt output to make sure that when the selection FET is on, the 12 volt won't backcharge my 5 volt. Another really important thing about InnoMux-2 is that we want to be able to monitor and regulate the outputs independently. That means I need two independent feedbacks So I have feedback 1 and feedback 2. So that's it. That's the circuit for InnoMux-2. So how does InnoMux-2 deliver accurate regulation on all of the outputs without the need for any DC to DC post regulators? Here's an example. When 12 volt drops below a reference point, the secondary side of InnoMux-2 knows it's going to send a request for switching cycle to the primary side through FluxLink. On the primary side, we turn on the switch, let the energy build up, then turn off the switch. Then on the secondary side, we turn on the SR, make sure the selection FET is turned off so that all the energy goes to 12 volt. 12 volt gets charged. Similarly, if 5 volt drops below a reference point, InnoMux-2 also knows. Also sends a request to the primary side, turn on the primary switch, let the energy build up, turn it off. This time on the secondary side, we turn both the SR and the selection FET on so that all the energy goes to 5 volt because 5 volt has a lower potential. 5 volt gets charged. So this is how InnoMux-2 works and why it can deliver accurate regulation on all of the outputs independently from each other. Let's look at some test results. I have a 5 volt, 12 volt design over here. The test condition covers across load and line. Line is from 90 to 265 VAC, and load is from absolutely no load to 100% full load on both of the outputs, so 5 volt and 12 volt. With all of these changes, the regulation on both outputs is still better than 1%. And this is because we regulate the outputs independently from each other. To learn more about InnoMux-2, visit power.com.